Hello everyone, I'm Uttam. Today we will be discussing about a very famous and most commonly used data structure, that is queue, with its real life implementation. Let's begin. What basically a queue is? A queue data structure is a fundamental concept in computer science used for storing and managing data in a specific order. Queue is a kind of data structure in which we store data. It follows a principle FIFO, first in, first out, where when we add the element in any queue, so the element that will be added first will be the first that will leave the queue. So it follows this basic principle. So FIFO principle in queue. A queue is like a line waiting to purchase tickets. Yeah, we can take an example of like we are standing in a queue for getting tickets. So the person that will be, standing or, entering the queue for the first in first will get the ticket and will dispatch from that in the same order. So when the second person will enter, the second person will get ticket and leave the counter. So this is the basic principle of queue, which is used in computer science also. So queue has various characteristics. So first is queue can handle multiple data. Yeah, we can create a queue of our desired size. It can be 10, 20, according to our needs, the type or the quantity of data that we want the queue to store. And there's also a thing that we can access queue from both sides, from rear and front, from both, and it is very fast and flexible to use. There are two main operations in queue: enqueue and dequeue. Enqueue is just adding a new element in a queue, or in real life you can understand by by another person standing in queue to get ticket. It's in the same way. And dequeue means deleting an item from a queue, and it means just and the element that has entered previously, so it will be deleted. Like in real life, a person that was already in queue, it got ticket and just it left the queue. It's the same DQ. Deleting an item is that's it. So NQ. NQ is the basic operation performed in a queue data structure to insert an element at the year end of the queue. So NQ is kind of operation which is used to insert new values to queue. Of course, queue is a data structure to store data. So NQ is used to insert data in queue. This operation is also referred to as push or insert. The NQ operation follows the principle of first in, first out that we have discussed previously also, which means that the element added first will be the first one to remove using the DQ operation. So NQ is used to enter an element, and the element that we enter the first will be the first to get out of the queue with the help of DQ operation. So DQ. DQ is an operation in a queue data structure that removes an element from the front end of the queue. It is also known as delete or pop operation. If the queue is empty, the DQ operation cannot be performed, and that is called an underflow condition. Yeah, so it is very obvious that when a queue is empty, there is no element in queue, so there is nothing to remove. So the DQ operation cannot be performed. So some more operations in queue. So as to access queue, to use queue in real life to store data, we have some more operations in which we can use queue in an optimized way. So first operation is front. This operation returns the element at the front and without removing it. So there is a condition that just we just want to know about the element that is in the front, without removing it. If we want to remove it, we can simply use DQ, but we don't remove it. We just need information about that element. So we will be using an operation front. Rear. Next operation is rear. This operation returns the element at the rear and without removing it. So it also performs the same, but it tells us information about the element that is at the rearest in the queue is empty. Our next operation. This operation indicates whether the queue is empty or not. So it is just a basic operation which we use to check if our queue has some elements or not, whether it is empty or is full. This operation indicates whether the queue is full or not. So this operation is generally used to to check the availability of space in queue, whether we can insert more elements in queue or not. Size. This operation returns the size of queue, that is total number of elements it contains. So size operation is used to get information about queue's size. It tells us how many elements we have entered and how many more we can enter in a queue. It is used to get knowledge about the size of queue. So now, as we have got the idea that what queue is, we have gone through its main functions. So now we will be implementing the same with help of our code in real life. So we will be taking example of any call center running telecom company. So we will be coding it and I will be explaining the code along with it. So we will be creating a class named, let's say, call center. Then we will be initializing an empty queue. Here we have created a class named call center and init function. So init function is a kind of initializer which will be called every time we assign anyone the same class. I have yeah this was now we will be defining another function named is a this will be telling us whether the queue is empty or not, if it contains any values or not. So I'm providing the documentation along with so that you can understand it in a better way. If it is true, so it will be returning length of self dot 0. So if length of queue is 0, so it will return true. So now we will be defining another function in which now we will be adding new elements to a queue. So we will name that what we can say function as enqueue. Yeah, I have taken one more argument as call because in whenever we will know will call enqueue function, then we will be delivering call a number which we want to add to our queue. That's why this blue line is here. Just to put it. Uh, the end of. So this will be used to add a number. Self dot So whenever we will call the function and insert any number, so it will append that new number into the queue which we named queue, which we created here, the empty queue. So whenever we call this function and try to add new number, so they will be added to this self.queue, and we will want a message to be printed like call call is added to queue. So this is the message that we want to, print along with us. Now we will be creating another function, that means the queue, when we want to remove any element from the queue. So here we don't have to specify another argument because we are not adding something, we are deleting. So if we will be adding a situation, if there is an element already in the queue or not. So so by this DQ call, first we will be checking, let's say there is no element in queue, so there is nothing to process. So there will be a message will be printed, no call in the queue. But if there is any, you know, if there is any element in queue, so it will be popped leftwards so that we can, if it is the last, and so there is nothing left, so it will be taken out from the queue. And so this is kind of, we are processing it. Now we will be defining another function named display menu. So by by calling this function, we want to a kind of display our services that we are providing this so that user can choose it by itself. And we will be printing print, you know, So this is a kind of menu that we have created. Whenever this function will be called, it will be displaying and will be asking for our choices that what we want to be done with our system. So now we will be defining another function. As above, we have, shown the choices that user can take, whether it want to enqueue any call, take you any call, or just want to quit from the service. So now we will be providing a platform where, after getting this menu, where the user can input its preference. Take user input and comment self, enter your choice. So as we have right wrote the program of enqueue call, dequeue, a menu. So now we will be, you know, just defining. We have defined now we will be assigning the class to some objects. Now we can add a documentation, main program. So we can create any object named call center itself, and we will assign the class named call center to it. We will be adding conditions while oh, some yeah. So whenever this object will be called, so in class this will be called. First of all, of course, the menu will be shown display menu that we have defined here only. Now we will be adding choice call center dot make user input. So this function will also be called where we can take user input. Now we will be defining condition based on input taken by user. If choice equals to 1, or equals to input and enter the call number. Call underscore center. So as if choice is 1, So here one means enqueue call. So when choice is one, the function enqueue call will be called and it will be asking for an input that what mobile number we want to provide that we want to be added in our queue. Else if any user chose so if the choice is two, so we know which function to be called DQ function that we have created here. So if choice chosen is 3, let's say, then 3 we defined as exit. So we will be printing the statement the call center program. Goodbye. So here we will break our else statement. Else, let's say if the user chose something else other than 1, 2, or 3, so we'll be putting it in another category and we will be showing print invalid choice. Please enter valid choice. So here is a program. Now we will try to run a program. So here as call center menu, it is displaying that call center menu. So let's say what we want. We want to enqueue any call. So we will be pressing 1, enter, enter the number that you want to queue. Let's say my number I want to get is this. So again, at the enter, yo, call added to your queue. So let's say we want another, let's say we choose 3 because we want to exit. So exiting the call center program. Goodbye. So this is a real life-based example on queue. I hope I help you with the concepts of queue. Thank you.